Okay, these are the notes for section 4.3, right triangle trigonometry. So you have already studied right triangle trigonometry in geometry, and you did it in algebra 2 as well. So we're going to continue to work on right triangle trigonometry and go a little bit more in depth with this. So the very basics are you just need to understand that a trigonometric ratio is going to be a ratio of the sides of a right triangle. There are going to be no units. So you're not going to say cosine of 30 degrees equals 5 feet or something like that. There's no units at all because it's a ratio and your sides are going to have the same units. So the units are going to cancel out. It's a ratio of sides. So that's why you'll hear me refer to it as a trigonometric ratio more than anything else, because it truly is a ratio. You have to also understand in a right triangle, the opposite and the adjacent side are all dependent on where the angle is you're talking about. So in this right triangle, here's my right angle. The hypotenuse is always opposite the right angle. If I were talking about this angle here is theta. If I draw this arc through the angle, it's always going to cross through the hypotenuse and the adjacent side. And then if you go straight across, that's the opposite side. If I reorient my triangle in a different way, and I'm talking about, well, this is my right angle, this is my angle theta. If this is the angle theta, once again, if you draw that arc through the angle, you're always going to cross the hypotenuse and the adjacent side. If you draw the arrow, it reaches towards the opposite side. And it's imperative that you understand this relationship. So we're going to be solving for sides in right triangles. And so here's an example. Here's my right angle. So opposite my right angle, this is going to be my hypotenuse. If this is the angle I'm talking about, this is 30 degrees. Here's my arc right there for the angle. So there's a hypotenuse. A is going to be my adjacent side. Don't think A always represents the adjacent side. I could have used the letter Z. I could have used the letter P. I could have used the name Sam. It doesn't matter what you call it. It just is adjacent to the angle that you're talking about. So then 7, in this case, is going to be my opposite side. Since I'm given my opposite side, I want to find my hypotenuse and I want to find my adjacent. But since I'm given the opposite side, I can find my hypotenuse using sine. And this is where you really have to know these terms. I have my angle, I have my opposite side, and I can find my hypotenuse using sine. So I have sine of 30 degrees is equal to 7 over c. When I cross multiply, I get c sine of 30 degrees equals 7. So c is going to equal c is going to equal 7 divided by the sine of 30 degrees. Type that in your calculator, but make sure that your mode is on degrees, or you use the degree symbol. So I get c is equal to 14. So that's what the hypotenuse is 14. There's no units on this problem, but if you have a problem that has been given units, make sure that you use those units. I can also find the adjacent side. So once again, I'm given an angle and I'm given the opposite side. So I have to come over here and find something with opposite and adjacent. And it's going to be tangent. Tangent's opposite over adjacent. I don't use secant, cosecant, and cotangent when I'm solving right triangles because I don't have those buttons in my calculator. So I don't use those. I don't recommend that you do. So I'm going to use tangent of 30 degrees. Tangent's opposite, which is 7, over adjacent, which I don't know. Cross multiply. oops, I knew it wasn't thinking. A tangent of 30 degrees equals 7. I just got ahead of myself. Divide by tangent of 30. I guess A is equal to 7 over tangent of 30 degrees. Type that in the calculator and I get 12.1. So I get my adjacent side is 12.1. And just as a rule of thumb, I most of the time just go to one decimal place. When it comes to quizzes and tests, I will tell you what I want you to round to. Okay, now if you're solving for an angle, it's the same process. I don't need to solve for angle C. It's a right angle. It's 90 degrees. So I'm not going to solve for that. I can solve for A or I could solve for B. It doesn't matter the order. Let's just keep it alphabetic. So let's solve for A first. I am given all three sides, so I don't care which trigonometric ratio I use. I will go ahead and use sine. I know sine of angle A. Opposite is 5, hypotenuse is 13. So I want to find angle A. So angle A is going to be the inverse sine of 5 over 13. And you studied inverse functions in Algebra 2, and we've studied them some in here as well too. We've studied exponential and logarithmic functions. We have studied cube root and cubic functions, and those are all inverse. So at this point I would grab my calculator and I'll show you what to do. Okay, first of all, I'm going to make sure my mode is on degrees, and it wasn't, so I put it on degrees. Then I want to do inverse sine. So I've got sine right here, but I want to do inverse sine. So I'm going to do second and sine, and I've got the 5 divided by 13. So 22.62 degrees. So 22.6 degrees will be good enough. And then if you remember, angle B has to be complementary. So we could just do 90 degrees minus 22.6 degrees. And I get 67.4 degrees. And that's one of the reasons you had to learn about complementary angles. I could have done it using trig as well. And it doesn't matter. Whichever way you want to do it is fine. But a triangle has to add up to 180 degrees. If this is already 90 degrees, then I know angle A and angle B are going to be complementary. The other thing we'll be doing with these problems is word problems. And angle of elevation and angle of depression is going to come up in some of these word problems that we're doing. So if you're standing up here and you're looking down, if you're on the top of a ladder, if you're on a top of a hill, you're on the roof of your house, and you are looking down, this angle right here is considered the angle of depression. If you're on the ground and you're looking up, so you're down here on the ground, you're looking up, this angle here is going to be the angle of elevation. And what happens is this angle of depression and this angle of elevation are congruent. And that comes from geometry. If I have two parallel lines, so let's say this is angle or line L and this is line M. Line L is parallel to line M, and I cut them by a transversal. So there's my transversal. It just means another line that's cut straight through them. Opposite interior angles are congruent. It's one of the theorems from geometry that you will use throughout this whole course. It's very, very important. You don't have to remember it, but I just want you to see where it comes from.